Once we have modeled projects as arrays of interdependent decisions, we can introduce two main dynamics that characterize every project regardless of its object, industry, technology: the cost to change and the uncertainty. We can start by analyzing a quote by the chief engineer of a Boeing 777 project. You have 5,000 engineers designing an airplane. It is complicated for these engineers to coordinate themselves with two-dimensional pieces of paper, or for a designer who is developing an air conditioning duct to walk over to somebody who's in structures and say, "Hi, here's my duct. How does it fit into your structure?" It is challenging with two-dimensional pictures. So, we ended up using physical mock-ups and, quite honestly, also using the final assembly line to complete the integration. And it was costly. You end up with an airplane that is very difficult to build. The first time that components come together is on the assembly line, and they don't fit. So we had a tremendous cost on the first few airplanes to make sure that all the parts fit together. This interview clearly describes that the impact of changes at the end of the project is huge. Unfortunately, though, it also shows that many mistakes are made in very innovative and unique situations, and usually they become evident only in the later phases of the project. This dynamic is known as the cost-to-change curve. According to this curve, as the project time increases, the cost and time of change increases more than proportionally. Attention! This is not the project cost curve, but it is the curve that describes the required cost and time needed to introduce changes during the project. Let's make an example. Assume we are developing a new motor vehicle, and we are at the initial stages of the project. In this phase, we are still dealing only with a computer-designed version of the car. The physical model does not exist yet, but we could easily have a detailed rendering of a new vehicle. Let's imagine now to show the rendering to the company's marketing director. And he says that it is crucial to introduce folds on the hood to make the car more aggressive. This is a recycle. It will be necessary to go back, modify the hood file, reintegrate it in the master digital file, and continue with the project. Still, the impact of these changes will be limited, as we have not yet any physical change involved. Now, let's imagine what would happen if the same change was required in the project final phases. In this case, we would already have the physical car, done the crash test, released pictures for a press release, bought, assembled and tested the equipment for the assembly line, and so on. The cost of this change would now be huge. Not because the change is different, but because it happens later in the project. Therefore, if we consider any change to a project, the cost and time connected to it increase exponentially over time. This means that in every project there is a point beyond which big decisions can no longer be made because they impact the project cost and time too severely. Anyone who has managed a project experienced that when errors and problems emerge in the final stages, the cost and time to eliminate them are unsustainable. The only possible alternatives are to terminate the project or to undermine the quality of the output. In addition to the cost-to-change curve, another curve represents each project's second main dynamic, the uncertainty curve. The basic idea is that when we start with a project, we know what we want to achieve, but not always how to get there. Remember that projects are suitable to obtain new and unique outputs. We do not have experience with it. Therefore, we will have to make some decisions pondering them as much as possible and accept that these decisions could be proved wrong during the project. So, at the beginning of the project, we have a high level of uncertainty, while at the end of a project, we usually know exactly how we should have done it. Also, in the case of uncertainty curve, by symmetry with the previous one, there is a time before which we cannot acknowledge that what we made was a mistake. By combining the cost to change curve and the uncertainty curve, we can say something quite interesting and not necessarily intuitive. Considering the project total duration, there is a window of opportunity, that is the real time slot in which we can modify the project, that usually is way shorter. In the beginning, we do not have enough knowledge to change possible wrong decisions, and in the end, even if we have that knowledge, we cannot change our decisions because of the high cost and time connected to that change. Project managers should carefully consider this combined effect when making decisions, because it largely impacts the project strategy. One main objective for any project manager should be to enlarge as much as possible this window, to create options to correct the project trajectory in the future. There are two main strategies to widen the opportunity window. On the one side, we can act on the uncertainty curve by lowering it in the initial phases. This is called front loading, and by applying it, we will anticipate changes to the initial stages when their impacts will be less severe. Another option is to act on the cost to change curve by lowering it in the later stages of the project. This is called flexibility and allows the introduction of relevant changes even near the end of the project. These two strategies lead to two philosophically different models of project management, namely stage gate and agile. We need to go more in depth of these approaches to understand how different they are, but also how we can combine them into hybrid approaches.